Now first row multiplied with third row, the second. This is A into C is minus AC. B into B is plus B square. C into A is plus CA or AC. This AC, AC, AB, AB minus AB. This is C square plus B square. C square plus B square, okay. And this is twice BC minus A square, alright. We have opted. Now second row multiplied to first row. So it will be minus AB. It is minus AB. B into minus AB. C into C is plus C square. A into B is plus AB. Right. First row corresponding element of first row multiplied with corresponding element of second row, the first. So okay, now second row multiplied to second row, the second matrix, second determinant. B into B is minus B square. B into B minus B square plus C into A is CA. Let me take CA or AC. Okay. Then plus AC of CA. AC, A into C, AC or CA, no problem. Now third row, sorry, second row multiplied with third row is still, third row is left. This is minus BC, B into C minus C minus BC, C into B is plus BC, A into A is plus A square, BC cancelled out, minus AB plus AB cancelled out. Okay. Now third row multiply to first row, second row, third row to obtain the first, second, third element. C into A is minus AC, CA. A into C is plus CA or plus AC. And B into B is plus B square. Now first row, second row. C into B is minus BC. A into A is plus A square. B into B into C, second row we are taking. Well, A into B into C plus BC. BC cancelled out. Now third row. So C into C is minus C square. AB, A into B is AB. B into A is plus AB again. Okay, so resultant determinant, let me write here, is twice BC, BC plus BC twice BC minus A square. Here we are obtaining only C square. This is only B plus B square only. Now this is C square here. This is twice AC twice CA twice CA minus B square. This is the resultant CA, okay, and minus B square, right? And this is A square only. Then AC cancelled out, minus AC plus AC. This is only B square. This is only A square because minus BC plus BC cancelled out. And this is twice AB minus C square. Okay, this is the resultant of multiplication of these two. But what is the final result? That is the question. This is the second part we have obtained. This is obtained. First part is obtained here. Now resultant of this will be this. That we have to prove. Now if I take, okay, this is proved. First part is proved here. The first part is proved. Then after multiplication we have obtained this part. Now this is to be obtained. So what we see here. Now if I take this minus ABC, the second determinant here, the second determinant on top, this is minus A minus B minus C, and this is C B A C, and this is B A. Okay, If I take minus 1 common from this one, it will be A, B, C, C, A, B, and B, C, A. Now, if I interchange third column and C2, so C2 is replaced, C2 is replaced as C3 and C3 as C1. Again, minus 1 will come, minus 1 sum will come here. Let me write here minus 1 whole square into, this is nothing but ABC. What I've written? I've written down the third column, C2 times to C1 and C1 to C2. So the third column we have taken at the place of second one, third column, second column. They are interchanged. If we interchange, naturally minus sign is come. When two rows are interchanged, one row replaced by second row or second row replaced by first row, but they are interchanged, then there is minus sign. So this is minus sign here. What we have done, we have taken third column to second column, third place. So this is now A, B, C. Now let me write first, the first column. Now second column is third column, B, C, A. And third column, second column is third column, which is C, A, B. What we see here, minus 1 whole square is plus 1. And this is now ABC, ABC, BCA, CAB. Same resultant is obtained. This is whole square. Okay, so now what we obtain here, this is equal to only A, B, C positive, B, C, A and C, A, B. This is the value because minus 1 whole square is plus 1. How we obtain minus 1 whole square? First we took minus sign common from the first column. It will come out as minus 1. This is minus 1 we are taking common. This is ABC now positive ABC. And these two columns are same. But in third position we have taken this third column as second column is. So we have interchanged the two columns, second and third. We interchange, naturally we minus sign, we take the minus sign. Minus 1 will again come to this minus 1 whole square. Minus 1 whole square is positive. This is now ABC. The same determinant is obtained as the first determinant is there. First determinant is ABC, BCA, CAB. Same whole square is there. So let me write now. Therefore, this is equal to nothing but ABC, BCA and CAB whole square. Now this is whole square. The same determinant. The whole square of this determinant is there. What is the value of this? Now let me open this determinant by first row. It will correspond to the first row. By the element of the first row and their cofactors multiplication. We will obtain here. This whole square we have obtained. Now A into BC. Let me write A into BC minus A square minus sign in between. We write the B element and its cofactor. Its cofactor is negative value. In minus 1 raised power 1 plus 2, that means 3 odd number, which is negative. B into B square, B into B, and this CA minus CA. Now plus C, this C, third element of the first row. What is the cofactor of this then? Minus 1 is 4, that will be positive. And this is BA or AB minus C square. Okay, so now this is whole square. So let me again multiply. This is BC minus AQ minus BQ minus plus ABC. Or this is ABC. First is ABC. ABC and this is minus AQ and this is BQ plus BCA or ABC. Again this is plus ABC minus CQ whole square. What we obtain here, this is nothing but 3ABC even if I take minus sign outside, but it is minus, it is whole square, it will be positive. We can write these values as positive and the third one is a negative. Can be changed. Let me first write them as it is. AQ minus BQ minus CQ whole square. We can write them because whole square, if I take minus sign common outside, it is whole square of this, it will be positive. We can write AQ plus BQ plus CQ, and now it will be minus ABC, 3ABC whole square. This is the right hand side. AQ plus BQ plus CQ minus 3ABC. Minus 3ABC has become because we have taken minus 1 common out of this square, then bracket and over square, or I mean whole square of that. So that whole square will make minus 1 sign as positive, and this will sign will change. And the same that we have often as proved. This is proved here. So question number 2. Question number 2, I mean, we have proved. Hence, proved. The same value has been proved. This is the same value we have obtained. We have obtained. This is question number 2. Let me talk about question number 3. So what does question number 3 say? Let me check it. Okay. Now question number 3. Question number 3 says, prove that the determinant this is a multiple of the determinant this and find the other factor. Okay. Now let me first write this. What is the determinant given to us? Question number 3 is here. Okay, to prove that the determinant this has, to prove that the determinant, which one is twice b1 plus c1, c1 plus 3a1, okay, and 2a1 third element, 2a1 plus 3b1, yeah, and this is twice b1, b2, this is twice b2 plus c2, and c2 plus 3a2, 2a2 plus 3b2, okay, then twice b3 plus c3, and the second element c3 plus 3a3, twice a3 plus 3b3 is having, this determinant has a1 b1 c1, that we write a1 b1 c1, a2 b2 c2, and a3 b3 c3, okay, as it's one of the determinants. So other determinant which multiplied with this determinant will give us this result. Let me write them. If I take solution is here, we have to find out the second part of this. To prove that this determinant has this as one of its factor of determinant. The multiple of the determinant, this is one of its multiplicative determinant. One of the multiplied determinant is here, determinant. Okay, one of the, there are two determinants which are multiplied. Now this is one. What is the other determinant which multiplied if with this one? Then we obtain this. So this is one of its factors. One is factoring determinant. That is we have to prove. So now let me take. Now let us take the two determinants. The two determinants as So let me take the first determinant which is given to us: A1, B1, C1, A2, B2, C2, and A3, B3, C3. Now if I multiply this with another determinant, okay, so now first row is to be obtained by multiplying to first row. So this first row elements, this is 2B1, C1. It means in place of A we have 0. So A element A1 is not there. A1 multiplied to 0 is 0. B1 multiplied to 2, this is twice B1. Alright, C1 multiplied to 1 is C1 here. The first row is having 0 to 1. Second row will have, if I multiply the first row to second row, then those elements are obtained to A1 is 3 times, that means 3 is here. C1 is not there, C1 is there, but B1 is 0 and C1 is 1. Okay, then the third element of the first row is obtained by multiplying the third row to the first row. A1 into 2, so twice A1 is there. B1 into 3, it is 3 here. C1 to 0, because it is 0 here. So this is the second determinant, second factor determinant, which if multiplied to this, let me take what is the resultant of this. Now the resultant determinant after multiplying these two will be obtained as A1 into 0 is 0, twice into B1 is twice B1, C1 into 1 is plus B1. Again first row multiplied to second row, this is 3A1 plus B into B1 into 0 is 0 and C1 into C is plus C1. Now first row multiplied to third row, 2 into A1 is twice A1, B1 into 3 is plus 3B1 plus C1 into 0 is 0. This is the first row's elements. First element is twice B1 plus C1, 3A1 plus C1, 3A1 plus C1, 3A1 plus C1. Second is twice A1 plus 3B1, exactly right. Okay, so this is that factor determinant. Okay, now the result of this first row multiplied or second row multiplied to first row to obtain the first element of the second row of the resultant determinant. A2 into 0 is 0. B2 into this 2 is twice B2. C2 into 1 is plus C2. Now second row multiplied to second row, which is 3A2 plus C2 plus B into 0 is 0. B2 into 0 is 0. B2 is not there. Now second row multiplied to third row, twice A2 plus 3B2. Now third row multiplied to first row, second row, third row. First row multiplied to, third row multiplied to first row. 3 into 0 into A3 0. Twice B3 plus C2, C3, C1 into C3. Yeah. Now then A3 into 3 is 3A3 plus B3 into 2 is twice. No. What we are doing? First multiplied. The first row multiplied A3 0, C1 into C3 into 1 is C3 plus C3. Now this one is 3A3, 0 into B3 is 0 and C3 into 1 is C3. So this is the second element after multiplying the second row to third element, third row. Third row multiplied to second row. Now third row multiplied to third row, that means twice A3 plus 3B3. C3 into 0 is 0. So this is the factor. Hence, the other determinant, the other or second determinant or second determinant is this one. Which one? 0, 2, 1, 3, 0, 1 and 2, 3, 0. This is this determinant. This is the answer. Second determinant with which this determinant is multiplied to obtain this one. The resultant determinant is this. Is this the answer here? This is the formula for this. This is question number 3 we have done. So okay, now let me take question number 4. What is question number 4 here now? Let me check. So let me fix it. Fixing now the 4th question. Question number 4 is of kind. Let me now check. Question number 4. Of course, 4th question says if A1, A3, B1, A1, A2, A3, B1, B2, B3, C1, C2, C3 are the cofactors of the elements. This, okay, respectively of the determinant B1, B2, C3. Now, so that this determinant multiplied to this cofactor is equal to that. Okay, so what is the cofactors? Question number 4. Let's talk about this. Here, the determinant of cofactors. Determinant of cofactors of a determinant which determinant? This is the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. Now, the cofactors of this determinant, they are the elements here A1, A2, A3, column wise. Now, let's say A1, A2, A3, B1, B2, B3, B1, C2, C3. Okay, let us take this column wise we are taking, because A1, A2, A3, B1, B2, that is given there. So let us take the here the determinant of cofactors of the determinant of a determinant is the cofactor determinant is capital A1, A2, A3, B1, B2, B3, C1, C2, C capital letters. This is the cofactors determinant. Now it says if it is multiplied, okay, to this. Now if A1, A2, A3 and cofactor elements are this, respectively of the determinant this, so that this is multiplied to the determinant. The A1, A2, A3, this is multiplied to this. This multiplied to this is equal to whole square of this. This is A1, B1, C1, A2, B2, C2, A3, B3, C3, whole square. This we have to prove that if this is multiplied to this one, then this is nothing but whole square of that. Okay, whole square of that determinant we have to find out now. Let us take that. What is this question? Now, if I multiply this determinant to this, now we know that the cofactors elements of the row and columns are multiplied. Corresponding elements. Now let me take the first row. The elements of the first row are multiplied the cofactors of the corresponding elements of other row. Then it is 0. We know that. Now let me write here this result. Solution we will find out. Solution. We know that if the elements of a or column are multiplied to the corresponding or multiplied to cofactors of corresponding elements. Let me write here, multiplied to the cofactors of the corresponding elements of other row or column, then it is 0. The elements, if you know that if the elements of a row or column are multiplied to the cofactors of the corresponding elements of other row or column, then its multiplication is 0. What does it mean? Let me just talk about that. Okay, that will give us that if I multiply the other cofactors determinant, okay, a1, a b1, c1, the other cofactors determinant, if I multiply this first row of the cofactors of the first row to the first elements or elements of the first row of this resultant, I mean the second determinant, then they are okay. A1 into A1 is okay, plus B1 into B1 is okay, because B1 into B1, capital B1 is okay, because this is not 0, because they are multiplied to the cofactors of the same rows elements, corresponding elements of the same row, okay, or then it is not 0. Let me just write, therefore let me multiply this, or let me write first this one, A1, B1, C1, we write any A2, B2, C2, and this is A3, B3, C3. Now if it is multiplied, let me write this A1, A2, A3, B1, B2, B3, C1, C2, C3, capital. This is a smaller one, these are the capital one. Okay, so the resultant of this will be, let me write here. So first multiplication is A1 into A, capital, plus B1 into capital B1, plus small c1 into capital C1. So this value is there. But if I multiply this first row to cofactor of the second row, then it is 0. But let me write here, A1 into A2, 0, plus B1 into B2, 0, plus C1 into C2, 0. And third element is this, A1 into A3, A1 into A3, plus B1 into B3, third rows elements, plus C1 into C3, these are the zeros. Okay, and now the first row multiplied to first row, this is A2 into A1, 0, plus B2 into B1, 0, but this is also 0. If you multiply the elements to the cofactors of the another row, cofactors of the corresponding elements of another row, this is now first row cofactor, and second element is the elements of the second row, A2, B2, they are the elements of the second row, but cofactors are of first row, this is 0. Similarly, this A1 into A2, 0, B1 into B2, 0, C1 into C2, 0, A1 into A3, 0. This is the rule we have applied previously. Okay, when we were multiplying this kind of, I mean, this law we defined. So this is 0, plus C2 into C1 0. But when second row multiplied to second column, then it will give us A2 A2 plus B1 sorry B2 into B2 plus C2 into capital C2. Same. So element of the same row multiplied to cofactor of the same element of the same row, then it is the value of the determinant. Okay, so this is the others are zeros. And the third element will be this one. This is A2 into A3 0 plus B2 into B3 0 plus C2 into C3 0. So this is the cofactors of the third row multiplied to elements of the first, second row. So this is the corresponding elements. Now third row multiplied to the first row, second row, third row. Only third row elements will be there. This first one is A3 into capital A1 plus B3 into capital B1 plus C3 into capital C1 0. Now A3 multiplied to second row, this is A3 into A2 0 plus B3 into B2 0 plus C3 into C2 0. And this is elements of different row and cofactors of different row, they are zeros. This rule we defined previously. Okay, the same rule is applied. So here now A third row multiplied to third row, then it will be there. The values are A3 capital A3 plus B3 into capital B3, value is there. C3 into capital C3. What is the resultant of this? Let me write. This resultant, this A1, B1, B1, C1, C1, A2, B2, C2, C2, and A3, B3, A3, B3, C3, C3. These values are the values of the determinant. Let me write here. This is determinant A. Let me write this delta 1, delta, positive value delta. This is 0, this is 0, 0, this is delta here, value of the determinant, and this is 0, 0, and this is also determinant value.